let us consider this problem based on capacitor. The slab of material of dielectric constant K has the same area. So we have the slab of dielectric constant K. It has the same area as that of the plate of parallel plate capacitor. It has a thickness. Which one? The slab has the thickness 3/4 of the D, where D is the separation of the plates. So we have a parallel plate like this. This is the parallel plate capacitor. In between then these two capacitors, actually the distance between them is D. So we have another insulator. Let me indicate by this red line. This is the insulator. This is the slab. And its thickness is, that is T, is equal to 3/4 of the distance between the two plates. Now, how is the capacitance changed? So we have to mention about the change of capacitance when the slab is inserted between the plates. It means before inserting the slab, after inserting the slab. So one is without the insulator. Another is with insulator. Okay, so these are the two cases we are going to have. So we have the formula, that is the electric field between the parallel plates. Okay, so E naught, the electric field between the parallel plates, is given by the potential divided by the distance. Okay, right. And the potential difference when E is equal to E0 is there, then it is indicated by V naught. Now when the electric field is, the insulator is introduced, that is dielectric is introduced. So when dielectric is introduced, this is represented by E is equal to E0 by K, where K is the dielectric constant. Now we want to show the potential difference. This is given by the equation. So this is the first equation. This is without insulator, that is without the dielectric slab. This is with the dielectric slab of dielectric constant K. Right? Now the potential, the net potential difference we have to work out. So that is given by, the potential difference is given by, we have to include these two. Therefore, V is equal to E naught plus E. Okay, so this is another equation. So let us substitute these two values here. Therefore, V is equal to, now E naught V0 by D, V naught by D plus E naught by K plus E naught by K, is it not? So E naught by K. Now it is clearly indicated the distance is, in this case, D, and it is because of the introduction. Now what it has happened, it becomes 1/4, because 3/4 is the thickness, means the remaining is 1/4 only. Am I right? Okay. So it has 1/4. Therefore, E naught V is equal to, this V naught is already given as, that is E0 into D. We can make use of this equation because we have E naught is equal to V naught by D. Therefore, V naught is equal to what? E naught into D. Similarly, here we have to include the E also. What is E here? We have to interpret in this way. So we have V naught is equal to E naught into D, because this is the original formula. Okay. So V naught is equal to, what is E naught? I mean, what is D? Here it is 1/4 of D. Are you able to follow? So E naught into 1/4 of D. Why? Because it is already 3/4. The remaining space is 1/4. So I have taken the distance 1/4. Okay. And what about the other one? See, the other one is, that is 3/4. Okay. That is the width, voltage with what? Insulator. Okay. So the voltage with insulator is E naught voltage with the dielectric medium or with the slab. So that is given by E naught divided by K into D. This D is nothing but 3/4 of D. Correct? Now we have to add these two. Therefore, the net potential will be, that is E0 into 1/4 of D plus E naught by K into 3/4 of D. Are you able to follow? Take down 3/4 of D. Now, which is common here? E naught D is common. We can take outside the bracket, and therefore 1/4 plus what? 3/4 into D, and that D has been taken here, right? So, and this is 3/4 K, actually 3/4 K. Therefore, E naught into D, and take LCM 4K. So this becomes K plus 3 times. Okay, K plus 3, right? So V naught into what? E naught into D into K plus 3 whole divided by 4K, where K is the dielectric constant, E0 the electric field, D the distance between the two plates. So this is the potential difference. Now, what is asked here? How is the capacitance changed when the slab is inserted between the plates? We are going to talk about the capacitance. We know capacitance is given by the equation C is equal to Q naught by V. So this is the formula for capacitance. Okay. So in this case, we can introduce, instead of V, we can include this. Therefore, C is equal to Q naught divided by, instead of V, you can write down this one. Is it not? That is E naught into D into, and this is reciprocated, K plus 3, and here reciprocated as 4K. Is it clear? Okay. Right. So this Q0 divided by K plus, and we have V also, is it not? Right. So Q by, here we have V. So we have to include that one also, into V. We can put into V. Okay. Right. Now this Q0 by V, Q0 by V. So that can be what? That is because Q0 and here E0 into V. So this together can be called C. What is C? Capacitance. That is equal to, and you have 4K divided by, and you have this K plus 3 term. Okay. So we know Q0, E0, D into V can be called C0. Okay. So therefore it is equal to, the capacitance is equal to 4K divided by K plus 3 into C0. So it is based on the dielectric constant of the insulating medium which is inserted between the two plates, that is parallel plates. Are you able to follow this? Okay. Any question? So let me recap. The slab of material dielectric constant of material of dielectric constant K. So K is the, dielectric means insulator. So by introducing an insulator between two plates, we are going to discuss how the capacitance changes. So here the parallel plate capacitor has the thickness 3/4 D, and D is the separation of the plates. So the slab's thickness is 3/4 D. So the remaining place should be what? D minus 3/4 D, which is nothing but 1/4 D. Okay. So that is why we have taken E naught is equal to V0 by D, and based on that we work out, that is E, and also E is equal to V0 by K. So we have to include both. So when we include both, we are able to get this equation. Okay. And once we have got this one, now we introduce the capacitance, which is nothing but the ratio between Q naught and V, where V is the voltage, potential difference. So you can substitute this and get, and once again the Q0 divided by epsilon naught into D can be called, into V can be called what? That is the C0. So C0 divided by V. So it can be interpreted as C is equal to 4K divided by K plus 3 into C naught. Okay.